Good afternoon, class. I hope we are well today. Uh, if we have, I'll wait for about 5 minutes. If we have any question regarding the last class we did, you can type on the chat box so that I can attend to it before we continue to today's class. Please, don't let us flood the chat box with our name and matric number so that I'll be able to see the questions that are being posted. I'm more interested in the question you want to ask me, okay? So if you have any question, please put in the chat box and then I'll look at it. I'll just wait for a few minutes before I start today's class. So where we stopped the last class was that we were looking at the solubility table to refreshing our memory on what we already know. So we continue from there by taking a question on stoichiometry involving precipitation reaction. We are asked to calculate the mass of lead 2 sulfate that is formed in the reaction of 145 ml of 0.123 molar lead nitrate and excess sodium sulfate. These are the steps we need to follow. 1, we write the balanced equation for the reaction. Already in the previous class, we have been taught by Dr. Fatunsi how to write balanced equation. The beauty of any reaction is to see what happens between the reactant to form the product. And that we can easily see when we write a balanced equation for any reaction. So the balanced equation will show us how many moles of each of the reactants is reacting to form the product. So the next thing, after we have written the balanced equation for the reaction, we calculate the number of moles of the reactants. Then we determine which reactant is limiting. Also, we have been taught limiting reagents. So if we have 2 reactants coming together, one of them will be consumed totally. That one that is consumed totally is what we call the limiting reagent, and that is the one we shall use for our calculation. The one that is in excess will not be fully consumed in the course of the reaction. So meaning that we can't use it to calculate the number of moles. So normally when you have a reaction and one of them is a limiting reagent, it is that limiting reagent that we use to calculate the number of moles because it is the one that will be fully consumed in the reaction. The other one will be in excess, and then we will not be able to, it will not be totally consumed, so we can't use it for calculation. Followed by calculating the number of moles of products as required. Then we convert to the necessary units as required. Now, let's attempt to solve this question. The first thing, as we have seen earlier, is that we should write the balanced chemical equation. In this reaction, 1 mole of lead nitrate will react with 1 mole of sodium sulfate to give 1 mole of lead sulfate and 2 moles of sodium nitrate. If we look at this reaction, we will see that it is balanced. Okay? The next thing, just like I mentioned, look at the number of moles of the reactants that will produce the mole of the product. We have already been told that sodium sulfate is in excess, so we are not going to reckon with the sodium sulfate because it's not the limiting reagent. It means the limiting reagent is the lead nitrate. So lead nitrate, we produce 1 mole of lead nitrate, as we can see from the balanced equation, we produce 1 mole of the lead sulfate. Now, from the question, we need to calculate the number of moles of the lead nitrate that was consumed. The number of moles of lead nitrate that reacted with sodium sulfate to produce the lead sulfate. How do we do that? We are given the volume of lead nitrate and we are given the molarity. So we know that our molarity equals number of moles over volume. So number of moles will now be molarity times volume. And then we have 0.123, which is the molarity, multiplied by the volume. Always remember to convert to DMQ. So when we multiply together, we shall get 0.0178 mole or lead nitrate. So 0.017 moles of lead nitrate was what took part in this reaction. Now, from the equation of reaction, 1 mole of lead sulfate was produced from 1 mole of lead nitrate. So, since the ratio is 1:1, it means 0.0178 moles of lead nitrate, we also produce 0.0178 moles of lead sulfate, going by the balanced chemical equation. To now convert to mass, we know there's a relationship between the number of moles, the mass, and the molar mass. The molar mass of lead sulfate is 303.26 grams, which is equivalent to 1 mole. So number of moles equals mass over molar mass. So the mass will now be the molar mass multiplied by number of moles. So we multiply the molar mass, 303.26, by the number of moles, 0.0178, and that will give us 5.40 grams of lead sulfate. Okay, so that is how we use the information provided to get the amount or the mass of the lead sulfate that is produced as precipitate. Now, moving on. Somebody said the oxygen is not balanced. Why is the oxygen not balanced? Go back to the equation. The oxygen is balanced. There's nothing wrong with the oxygen. Look at it properly. So the next that we are going to be looking at is the acid-base reaction. According to Brownsell and Lowry, an acid is a proton donor. A base is a proton acceptor. Just like the same way